In this talk, I will discuss how to theoretically interpret generative models aiming to generate images of arbitrary size. When generating high-resolution samples, we encounter two major issues. The first is the scalability issue in training. For traditional generative models like GANs, their model size typically must grow at least linearly with the resolution of the training samples. The second is obtaining high-resolution images could be quite expensive. All this leads to generating high-resolution images in one shot is computationally infeasible in most cases. Recently, one solution is to generate them in an incremental fashion, which requires removing a significant amount of pixels due to some inconsistent architecture. So we try to solve this problem in this study. We first provide an in-depth analysis of the redundancy in terms of the fraction of discarded pixels. Then we proved that by making small changes to the convolutional architectures, we can ensure that the generator is consistent and the stationarity transformation over spatial stochastic processes. The incremental generation will produce inconsistent image patches due to use of padding. The Hawk solution is to stitch properly cropped patches. It will discard many pixels as claimed in Theorem 1. One example is to consider generating 4K by 4K images using 9 blocks of layers. We will discard 43% pixels. We proved that if the generator is constructed using the transforms in the table, then the generator is consistent and stationarity preserving. We demonstrate our theory using a model based on spatial GAN and a single GAN with two modifications, using consistent and stationarity transforms, and using the fixed patch size training. In the task of the generative satellite maps, we trained our model only on 64 by 64 patches and can generate 1K by 4K map, even 2K by 2K and 4K by 4K maps. We quantitatively and quantitatively compared with the spatial GAN and PS GAN. Obviously, our model can accurately capture the terrain textures and have much lower FID score. We also trained on the test patches can generate 2K by 2K realistic looking images. We also use the model to extend the landscape view horizontally. Our model can generate different patterns. You can see more results in our paper. Thank you.